minus 1/2 log 1/2. Which is the insufficient. And this equals 3/2. Sorry?
You're subtracting -1/2, right?
Oh, you're right. Thank you. Any questions? Okay, this is A, this is B. C is gain of the data given pesticide.
The numbers themselves should actually be positive because the log is the negative.
There should also be like a minus in front of the first negative.
Just way too many negative signs. So it should just be like minus the value because the log makes the value positive.
Yeah, it's addition between.
It's addition.
Oh, you're right, I'm sorry.
It's addition between. Like we
sorry.
triple negative it, so.
Yeah, you're right, you're right. I'm sorry. So, yeah. Thank you. It should have paid me as I wrote it. Okay. So gain pesticide. So we split on, what did I assume? So the data itself is 1 bit, right? So the split is 1/4 is the pesticide is yes. But the data is pure there, so there's no entropy. I wouldn't gain anything. Minus 3/4. Which equals 3/8. Does anyone? I hope people are verifying that somebody else verified this at some point, because I don't trust my. Yeah. Okay. D. So the tree I came up with for D. All right. So suppose gain irrigation is 0.3 and gain fertilizer is 0.5. So we'll select an appropriate root node. So we want to have the greatest gain, so we'll split on fertilizer. And fertilizer splits into organic and conventional.
If we have conventional and that's low.
Huh?
But if we have conventional and that's low.
We do?
Yep, it's pure.
You are correct. And on this side, we have irrigation. And I don't know if this is the only shortest tree. But
Yeah,
that's what I came up with. None is low, and else. And you could draw 2 if you want, but else is high.
that is the shortest tree.
See, if you know the answer ahead of time, it'll take very long off. Any questions?
I just had an observation of the table. Like
Yeah.
3 of the rows were the same. Like 2, 4, and 5, they're like exactly the same
Right.
rows. So it's that like
Yeah, 2, 4,
4 and 5.
Traditional again, we know.
Yeah, when you actually redid the table from your first draft,
Yeah.
you didn't just change the 6 and 7, which were flipped. It looked like you also changed above there as well. So
It makes the code really short.
yeah,
Is what we saw last time.
yeah. that's
All
what
right,
it is.
ignore this until, you know
That
what?
explains why our tree was like one layer. We're like, oh, we found something. One
I
layer
mean,
deep was like.
So there was
God.
one draft, and then there was a second draft last night, and then there was a third draft this morning.
Ah, so we're on the second draft.
All right, let me fix this. table. I'm really sorry.
No, there's nothing wrong with it.
Yeah. Maybe it's what I meant.
Or have we waited for it to?
Yeah, it doesn't matter. I'll take a look, but I think actually I probably made the table and didn't care and didn't pay attention.
It's just really weird. There's no pesticides, organic, and insufficient irrigation. Somehow there's a high yield.
Also,
Huh.
did you mean to put the parentheses before the equal sign? For gain at S irrigation is equal to 0.3?
No, I didn't.
Okay, so.
Thank you. Yeah, you're right. No, what happened is I cut and paste and then I went back and put it in parentheses and it's not gonna.
Wait, what's incorrect?
This is
Minor
obviously, the
notations.
function's not over the,
Irrigation not
the
even
probability or something. Yeah, no, you're right. Yeah, I do promise you the exam is much more proof All right, so this here is this problem. So this is clearly just a smoothing problem. So how I did this is I made a little table. It probably has mistakes in it. 1 minus 1. Okay, and this is x1 equals 1. x7 equals 1. And these are the probabilities I get. So if y equals 1, this is just the top two. So the probability that x1 equals 1 is 0. Does everyone see how I'm getting this? So just these two. X equals 1, 0. So 0, 0, 1 half, 1, 0, 0, 1 half. And then for the bottom, I got 1. Please verify. 0, 0, 1 half, 1, 0. Anyone disagree? I'll look quickly. 1, 1 half, 0, 0, 1 half, 1, 0. Yeah. So in that case, P of y equals 1 given x5 equals, so x5 is there's a 1, so we have a 0 right there. And P of y equals negative 1 given x5 equals, it's 1 times 1 half times 1 times 1 times 1 half times 1 times 1, I think.
Again, what's x5 again?
It's
Oh,
It's the
it's
training.
this one here, this testing example.
Oh,
That's what you meant.
Yeah. At x6, so this isn't really a problem. You could predict negative 1, right? P of y equals 1 given x6. I mean, the question I asked is why is there a problem with x6? So really you didn't have to do anything with x5 yet. And this equals 1 times 0, dot, 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 equals 0. P of y equals negative 1. Given x6 equals 0 right from the start. So my problem is that everything zeroes out and it's not interesting. So how do you solve this?
less smoothing.
You can use smoothing. Excellent. So the cheater way of smoothing this is to just add 4 new examples. We'll call them 4, 7, 8, 9, 10. and they're just ones for these, right? And zeros for these. Is that right? Wait. Wait, we want to add, so we want to add a 1 to everything is what it comes down to, so it has to be a 0 when it's not 0.
So you say modulo 2,
You
basically?
want to do one stew, or do one of the 1 rows for y equal 1 and one of the 1 rows for
Yes, that's what I want.
Yeah.
Which I can still do. I meant to do that, yeah.
That's what I was thinking we want to do, so we at least have a 1 in each case, so we're guaranteed that there's at least some minor probability.
So we want
Each of the rows.
this to be a -1, this to be a 1, -1.
Yeah.
Yeah. And then get your new counts. Or you can do Laplace smoothing correctly, where you add a 1 and you divide by the number you observe plus 2, right? Because you could have been a 1 or a not 1. So you just add a positive or a negative. Carry through. So you end up with a different table in that case. Somebody don't verify unless you've already done it, but write it down and verify it at home, I guess. 2, 3, 4, 5, 6, 7. 1 4, 1 4, 1/2, 3/4, 1 4, 1 4, 1/2, 3/4, half, 1 4, and something went wrong. 3/4, 1/2, 1 4, 1 4. And this is, 1, -1, -1, 7. And let's just make sure that at least one of them are right. So, given x1 equals 1, I should have put these together, but I have a 1 plus, so I have 4 examples, 1/4, yeah, that makes sense. I end up smoothing, and I can carry this thing out then accordingly. And to be honest, I don't know the answers, but you can do it. It's pick the right side and go through. If you were going to do this, I wouldn't expect you to actually. Well, yeah, I don't know. Yeah, I know. Just multiply, and it would be something like 1 over. It would clearly be like 3 over 256 or something. I don't know. It would be some crazy.